Hello, students. These are some of the extra problems that we had last week. We're talking about triangle congruence. So what were the three topics? We did in the textbook, we did 4-1, which was just called congruence. And the idea with that one was that we had a way to show that triangles were congruent, or any shape was congruent, by showing that it maps onto another one through a composition of rigid motions. Then we circled back to topic 2, section 3, where we talked about the triangle sum theorem. Okay, which was that triangles, the angles inside the triangles add up to 180 degrees. And then we talked about two types of triangles that are a little bit more special: isosceles and equilateral. And we did some math problems with those. So this video is going to go through some of the problems we had from the week and some that might appear on the final or on the midterm. So this is a good one to watch. And you can fast forward and slow down if you know how to do a problem, or you can pause it and try it and then check and see if you're right. So that's a good way to use this video. Our first topic was congruence, and we were talking, like I said, about showing that shapes were congruent through a composition of rigid motions. And we saw that if two figures are congruent, there is a composition of rigid motions that maps one onto the other. So we could show that triangle PQR is in fact congruent to triangle P prime Q prime R prime because of a reflection over the line N. Okay, remember capital R stood for reflection. So here's a math problem where you could explain to somebody why triangle ABC is congruent to triangle DEF. And the words which we just saw on the last slide will help us fill in the blanks. So triangle ABC is congruent to triangle DEF because there is a composition of rigid motions that will map each figure to the other. Congruent figures have the same size and shape because rigid motions do not change the size or the shape. You can see in this figure, it got flipped over this line. This line happens to be y equals -1 for those of you who are interested. And then it got translated over, and it was a straight translation of 1, 2, 3, 4, 5 units to the right. Just if you want to know how to write that, this would be triangle ABC. The first thing that happened is it got reflected over the line y equals -1, and then it got translated, capital T, 4 units to the right and 0 units up and down. And that yields, after you do that, you get triangle DEF. It maps it onto it. Okay, this one, no joke. I was looking at it for a long time. This is a slightly challenging. It can mess with your mind. If you see it right away, it's good. If you don't see it right away, you have to play with it. I tried reflecting it over the line y equals x. That didn't work. I tried to think about how I could rotate it, and I got confused. So I tried a whole bunch of things when I was playing around with this problem. And when I do it, it's going to look easy, but that's only because I put in at least 10-15 minutes thinking through how I could make these triangles match up onto each other. Some people see this right away. This is one thing that's challenging for me. And in class, if we were in real class, I would take tracing paper, I would trace this and then move it around until I got it to match up. And then I would go back and try to figure out, okay, what is it that I did? So after playing with it for quite a while, I thought, well, maybe we'll reflect it over this line. So I'm going to reflect it right. I'm going to take, we're trying to get GHJ to match up on KLM. So G somehow has to land where K is. Okay. So what I found would be good is to reflect it over this line. So G is going to stay there. G and G prime. G prime is a way to talk about the image, are going to be the same point because I'm reflecting it over a line that has point G in it. H is going to be 1, 2, 3, 4, 5 away from the line. So the reflection is going to be 1, 2, 3, 4, 5 through the other side. So H prime, the image of H, is going to land over here. It's getting reflected in this mirror, and then I can see it in the mirror down here at the bottom. Okay, and then J was 1, 2, 3, 4, 5 away from the line. So I have to reflect it down 1, 2, 3, 4, 5. You can see that this was a good idea because I already have the triangles starting to line, at least they're on the same kind of horizontal already. So I'm going to draw in the image, little wiggly. Okay, so I'm getting closer. I'm trying to get triangle GHJ on to map onto this triangle. Yeah, that's good. Okay, and it's almost there. You can almost see the mirror image already. Yeah, my original plan was to move it over to and then reflect it again, but I think I'm just gonna go for reflecting it over this line because it's right in the middle here. Like, I think I can get, we want J to land on M. So if I flip J over this line, it's 1 away and M is 1 away. So that would get J prime right onto M prime. And that's what I want. I want J and M to be in the same place. I want H to match up onto L. And H is 1, 2, 3, 4, 5, 6 away from the line. And L is 1, 2, 3, 4, 5, 6 away from the line. So it looks like I can do a double reflection on this one and I'll be okay. Originally I had a translation in there, but I don't think I need it. Okay, let's write this up. I have my plan, and I think, yeah, G is 1, 2, 3, 4, 5, 6, 7, 8, and K is 1, 2, 3, 4, 5, 6, 7, 8. So yeah, if I mirror it on this vertical line, it will get G or G prime onto K. All right, so that's my plan. Let's write it up. We're starting with triangle. I don't have a lot of room here, so I'll write a little bit small. We're starting with triangle GHJ, and we're trying to get to triangle KLM. And I'm doing a composition, I'm doing 2 of them, of rigid motions, and both of them are reflections. Do you remember if we use capital R or lowercase r? Capital R. I'm going to reflect it over this horizontal line. If I was really lazy, I could call this line M, but I'm going to push us a little bit. Line M has an equation. Line M has the equation y equals -2. Every point on this line, the y value is -2. Okay, this is the point 2, -2. This is the point 5, -2. This is the point -3, -2. So this line has an equation of y equals -2. Okay, and then I'm going to reflect it over this line. Again, if I was lazy, I could call this line N, but I'm not going to be. This line also has an equation. And the equation of this line is that all the x coordinates on the line are 1. This is the point 1, 0. This is the point 1, 2. This is the point 1, -3. This is the point 1, -6. So all of the x values on this line are 1. So we call this line x equals 1. X equals 1 is this line. So that's what I did next. I reflected it over the line x equals 1. Okay, when I did that, I got G to match up onto K. I got H to match up onto L, or map, and I got J to map onto M. Okay, this was another type of problem we had this week. Find one pair of congruent triangles and write the composition that maps one onto another. Again, if you want to pause the video and try it, and then unpause and see how I did it, you can do that. There's actually 2 triangles that I think are congruent in this situation, 2 pairs. I'm going to choose triangle ABC, and I'm going to find a triangle that looks like that to me. And that is triangle, well, I think these 2 look the same and these 2 look the same. So, and I didn't think this one through, so now I'm going to be a little uncomfortable because I really, really like to trace these and play with them. It might be another double reflection type of thing. Okay, you can watch me struggle through it. Triangle, I'm going to prove that triangle ABC is congruent to triangle, okay, and A, and it's going to match up onto D. D, E, F. How do I do that? I'm kind of looking from A to B. It's like they're 2 away from each other on the diagonal. B is 2 over and 1 down. And E and D also have this distance of, if I use the distance formula, this would be 1 squared plus 2 squared, which is 5. So ED is the square root of 5 and AB is the square root of 5. They're the same distance. So I know that AB is going to match up on DE. I could do the same thing for E and F. They're 1 apart and 3 apart, and B and C are also 1 apart and 3 apart. So if you want to really quick do the distance formula on that, that's going to be 1 squared plus 3 squared, which is 10. So these are the square root of 10. All right, I'm doing a lot of that quick in my head, but we did do distance formula a while back, and if you can connect that, that's awesome. Okay, so how can I get these to match up? I wonder if I can also do a double reflection on this one. So I'm going to reflect over the x-axis this time. So I'm going to take, maybe I'll get a different color. Let's do this pretty blue. Okay, if I put C prime here, that's a reflection over the x-axis. B prime is going to get kind of confusing over here. Ew, I don't like it when they overlap. It makes it more difficult. Okay, and then A prime was 1, 2, 3, 4, 5. So A prime is going to be 1, 2, 3, 4, 5. Ew. Super overlapping. It's a good thing I used another color. Well, I got it down there, but it's definitely overlapped. Ugh, I don't like it. Okay, so yeah, I got it down there. I'm gonna have to flip it again. And I'm gonna have to flip it over this line. Maybe I should use a different color. Okay, let me delete those. Okay, let's use this line. Double reflection again. And this time I'm reflecting it over like a -1, -2, -3, -3.5. So, But if I do that, does C get onto F? Does C prime land on F prime? Yeah, because it's 1.5 away and F prime is 1.5 away. So if I flip it over again, I've got it to match up. All right, let's write that out. We got triangle ABC. Okay, and what did we do to it? We reflected it. This is the same one kind of as this last time. And then we reflected it again. The first thing we reflected it over was the line X, which is the X-axis. Okay, and then the second thing we reflected it over was this sort of orange line, yellowish line. And that was the line X equals -3.5. Okay, and when we did that, we got it to map onto triangle DEF. All right, these are fun. Try it. How could you get this one onto this one? You might need a rotation for this one because they're kind of not the same orientation. That would be a fun one to try on your own and then work with some friends and see if you guys agree. All right, the second topic we talked about in week 5 was the triangle sum theorem. Let's review what that said. It said that the interior angle measures, so triangles have 3 angles, that's why they're called triangles. So angle A, angle B, and angle C, when I measure them and I add them together, I get 180 degrees. Okay, there was another piece of this lesson which is called the exterior angle theorem. And we don't even need this theorem, we can get away with not knowing it. But if you do know it, there's kind of a shortcut. It's that this angle out here, it's outside the triangle, that's why we call it exterior, is equal, the shortcut is that it equals the sum of these two. So if I measure this one and it's 60 degrees, let's do 50 degrees, and I measure this one and it's 55 degrees, then I would know that this is 105 degrees. And because I can just straight add them up, 50 and 55. Yeah. And that works because if we found this one and then we subtracted from 180, we'd take this one out. These two make 180, these 3 make 180. So if we take this one away, we just have that this one has to equal those 2. Okay, here's just an example to practice on. So I see a triangle, I see 3 angle measures, and 1 is missing. So the way to set this up is as a little algebra problem. You have something you don't know, plus 66 plus 74, and that has to add up to 180. And that's the only geometry you have to memorize here, is that the 3 angles inside a triangle add up to 180. And I'm pulling up my calculator really fast. So I'm going to do X, and then this is a little algebra problem. It's good for you to practice algebra and remember how to do stuff. This is 140. And then I'm going to take away 140 on both sides. And I like to show this out, especially some of you who are less comfortable with algebra. This is really important. We're making a 0 pair here. We're getting X by itself. The way we're doing that is we're doing the same thing on both sides. And this is going away because it's 0. And some teachers just say it goes away. That's BS. Okay, it goes somewhere. It goes to 0. Okay, I did it. I found X. And if I want to check it, I can, in my calculator, I can type in 40 plus 74 plus 66. And if that don't make no 180, then we're in trouble. So 40 and 74 and 66, it is 180. I'm very confident that I got it right because the angles inside a triangle add up to 180. Okay, here's another one. And if you know the shortcut, it's easy. If you don't know the shortcut, it takes a little longer. So let's do it the long way. So I'm going to put a little y right there because I forgot the shortcut, which happens. So I'm going to do y plus 64 plus 72 equals 180. Okay, and I'm using my trusty calculator. 64 and 72 is 136. Exactly like the problem I just did. So I'm going to take away 136 on both sides. And that's going to be 180 minus 136, 44. Okay, so I just found that this angle in here is 44. If I want to know the angle out here, I know that these two add up to 180. So I can do X and Y is 180. I wouldn't usually write that out, but I feel like it. Okay. Then I would do 180. I take away 44 on both sides. And that would show me that the exterior angle outside that triangle is 180 minus 44 is 136. 136, I saw that number already. Okay, this is the answer. Where did we see 136 already? I saw it over here. Okay, so this is the long way. It always works, and if you are not good at memorizing things, that you can always fall back on. If you do happen to memorize the other formula, you can just say that X is equal to 64 plus 72. Okay, that works because these three make 180 and these two make 180. And if you take the 44 out of the situation, you're just going to have these two angles add up to X. So I already added 64 and 72 up here, so I know X is 136. This is using the exterior angle theorem. If you like shortcuts, memorize this. If you don't like shortcuts and you can't memorize things very well, you can always work it out that way. Okay, this was just kind of a fun challenge problem. Just can you pay attention to details? The group in class did a really nice job. They counted the number of triangles made of one triangle. So the smallest ones. And they counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, and they wrote that down. Then they counted the number of triangles made of two triangles. Okay, so they went in here and they counted, see these two triangles also make a triangle. So they counted the number of those. And they got 1, 2, 3, 4. 1, 2, 3, 4. So there are 4 in each of these boxes. So 4, 8, 12, 16. There were 16 there. Then what do you think they did? These are just fun little puzzles. Can you play with mathematics? Do you enjoy playing with mathematics? Can you make a triangle out of 3 little triangles? No, that's going to be a quadrilateral. So then they looked at 4. 1, 2, 3. I see a triangle made out of 4. So I see one right here. Oops. Okay. And I just counted those up. So let's count those up. My brain saw this one first. Okay, you see it? So how many of those are there? There's 1, 2, 3, 4 along the outside. And then there's another 1, 2, 3, 4 in the inside. So there's 8 of those. All right, so 32, 33, 34, 35, 36, 37, 38, 39, 40. We're up to 40 so far. Okay, are there any more triangles in this picture? Any other size triangles? Yep. So the last thing we can do is we have What's the number of triangles made up of 5? You can't do. 6. Do we have any triangles made of 1, 2, 3, 4, 5? Oh, 6 we can't do. 8. One, 2, 3, 4, 5, 6, 7, 8. So this whole big one is made of 8 triangles. It's just a fun puzzle. I just threw it in because we're talking about triangles. Lots of congruent triangles in this picture. How many of those are there? There's 1, 2, 3, 4. Okay, total 44. That's what I got. If you want to argue with me, you found some more, you can let me know. And the last section from this week was isosceles and equilateral triangles, and these are probably ones you'll see on the midterm and final. So if you have an isosceles triangle, you know that there's a relationship between the two sides that are the same and the opposite angles. If two sides are the same, then the angles across from them through the middle of the triangle are going to be congruent. That's something you're going to see come up again in math classes. This is called the isosceles triangle theorem. This one's kind of interesting. If you have an isosceles triangle and you cut the top angle in half, it's true that the angle bisector, the thing that's cutting the angles in half, is going to hit the bottom of your the base of your isosceles triangle right at a right angle and right in the middle. So this is there's a lot to this. It says there's, if you have an isosceles triangle and an angle bisector, the place where the angle bisector goes through the triangle is going to be a right angle, and it's going to be the midpoint. It's going to be the middle. So you're allowed to say that there's a right angle here, and you're allowed to say that these two have the same marks because they're the same. Right, and then the last one is the equilateral triangle theorem. If you have an equilateral triangle, you know for 100% fact that all 3 angles are going to be the same. Okay, because these two are the same, and if you rotate the triangle and these two are the same, then all 3 have to be the same. How much are the angles inside a equilateral triangle? Well, if they're all x, they're all the same, x, 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 then, and they add up to how much? 180. Then how much do they have to be? What are the angles inside an equilateral triangle? A little math problem you could do is, in algebra, you could divide both sides by 3, and you can get x is 60. Okay, so inside an equilateral triangle, it's going to be 60, 60, 60. All right, so here's a fun one. Find the perimeter of triangle ABC. That's going to be a fun challenge. You can pause it and try it on your own, or you can watch me do it. Okay, or you can pause it part way through and see if you can do some of the steps. So first thing is I see a triangle, and my brain is like, okay, is it scalene or is it isosceles? So the first thing I want to do is find this angle. So the math problem I'm going to do is 132 plus 24, and that's 156. And then I'm going to take away 180, and I'm going to get 24. If I can find that this is 24, which it is, then I know that this triangle is isosceles. These two base angles are the same, which means what else has to be the same in this picture? Well, if this is 24, this side is related to it. And if this is 24, this side is going to be the same relationship. So I'm allowed to say, because these are both 24, that these two sides are the same. So I'm going to set up my algebra problem. I don't need this side right now. That's not important at the moment. Okay, what I know is that 2x and 15 is equal to 4x minus 5. Now I do some algebra. I'm going to take off 2x on both sides. And when there's variables on both sides, it's a good idea to focus in on the variables first. Just kind of standard best practice. This goes to 0. I still have 15. I have a 4x take away at 2x. Okay, this is called combining like terms, and that gives us a 2x. And we have the minus 5 just comes straight down. Okay, and then from here, I'm going to add 5 on both sides. So I'm going to do 15 and 5 is the same as 2x minus 5 plus 5. There's my 0 pair, it goes to 0. So 2 times some number is 20. Sometimes from there I can do it in my head. 2 times what makes 20? 10. Okay, or you can show the work the traditional way, which is to say 2 divided by 2 is 1. 20 divided by 2 is 10. All right, I have something important, but it's not the answer. Okay, in algebra class, yay, we're done, but that's not actually the answer. I'm not even going to put a box around it. I am trying to, as soon as you get the answer that you think might be the answer, you need to go back and read the problem in a geometry class. Because I don't want to know what x is in this problem. Sometimes I do. But in this problem, I want to know the perimeter. So how do I do that? Well, I know what x is now. Now I'm going to plug it back in. So I'm going to do 2x and 15 is going to be 2 times 10 plus 15, which is 20 plus 15, which is 35. So now I know this side is 35 units long. If I was walking from A to C, it would take me 35 steps to get there. Okay. Now perimeter is all the way around. Okay, so I'm going to be adding that to 4x minus 5. Now, if you're really understanding this problem, you might not do this part. Okay, this is 40 minus 5. Hey, what's 40 minus 5? 35. Okay, it better be. If that wasn't 35, that means I screwed something up over here, because I wanted these two to be the same. And if you were really like thinking ahead, you might not even do this part because you know this would also have to be 35. But it's a good little check. Okay, so 35 to walk from here to here, 35 to walk from here to here. We're at 70. I'm trying to find the perimeter. So I have to add up all 3 sides. Okay, so now I'm gonna figure out, now I need the 4x plus 12. I didn't need it until now, but now I need it. Okay, that's gonna be a 40 and 12, which is 52. And all of this, when I add it all together, is going to tell me what the perimeter is. That's 70, 80, 90, 100, 110, 120, 122, I think. If we want to write it really cool, we'd say the perimeter of triangle ABC is 122. You want to make people really happy, you write units on here. Okay. That's a really nice way to write the answer. This is the answer to the problem. X is 10 is not the answer. And hopefully I didn't mess up that math. Let me just check. 70 plus 52. Yep, I did good. All right. Whoa, what are we supposed to do here? There's not even any instructions. If there's no instructions, you want to just solve everything you can. I want to find all the information in this problem. So as much as I can. So I see an isosceles triangle. I see a 71-degree angle here. That's across from that mark. So what's up over here? 71. Okay, I see little angles that are have the same mark. Can I find out what those angles are? Yes, I can, because that says that they are that line segment BD or ray BD is bisecting these top angles. These top angles are the same. Maybe I'll make them X. I'm going to make them both X because we know they're the same. Okay, and you guys remember that weird theorem? Yeah, it's perpendicular. Okay, so I know that there's some 90-degree angles in the corner there. So can I find X? Sure. So I'm going to just look at one little triangle, and I'm going to do x plus 71 plus 90, and that's going to be 180. 71 plus 90 is 161. Okay, and that is 180 when we add x to it. Take away 161 on both sides, and I'm going to get that x is the same as 19. Ah, very small angle up there. So that's 19, and that's 19. Okay. So am I done? Did I solve everything? Yeah, maybe. I could say the measure of angle A is 71. I could say the measure of angle ABD is 19. I could say the measure of angle DBC is also 19. The only other thing I could do here is I could ask what's the measure of angle B. How would I do that? B would be the whole angle from A to B to C. So for that, I could use angle addition postulate. I can just add 19 and 19. And so the measure of angle B is going to be 38. And the measure of angle C was already given, it's 71. Can I find the measure of the sides? The answer to that question is no. We don't have enough. We know they're the same, but we don't know how much they are. So all we could do is say that x equals, or just s equals s for side, but it could be any number at this point. That's kind of interesting. Doesn't matter what the angles are. The triangle can be any size. Okay, here's another one. Oh, this one looks like fun. We can do the same exact thing we did on the other one. We could say this is 31. We could say these are 90. And I'm just going to do this on the calculator. I'm going to do 180 minus 90 is 90. 90 minus 31 is 59. So these are 59 up here. But now I have some information about this side. So I could say that this side is also 4. Remember that theorem? It says that it bisects the base. So those are the things I could figure out. Now, I know more math than you, and I could actually figure out these sides. You guys do not know enough math for that. Okay, we are not going to get into that in this class. So if we wanted to list out some things that we found, we could find PQ is 4. We could find PR is 8. We could find angle PQS and angle RQS. The measure of them is both equal 90. That's not very well written. We could find the measures are 90. We could find the measure of angle S is 59 plus 59, which is 118. Okay, we could find the measure of angle PSQ is 59. We could find the measure of angle RSQ is 59. And I can find the measure of these sides, but you don't know how. Haha. It's called trig. Okay, and the last, we got 2 more. So how do we do this problem? Well, I would just want to solve everything I can. In this problem, we're going to find all the angles. So I'm going to start with this isosceles triangle. And I know that this angle and this angle are the same. So I'm going to call them x for a moment. And even though it says find the measure of angle U, I want to solve everything. If I see a figure, I want to engage with it and find out everything that I can. So I'm going to start with the little triangle, and I'm going to do 72 plus x equals 180. So that's, I'm going to do the algebra. 2x is the same as 70, plus 72 is the same as 180. 180 minus 72 is 108. I'm going to do this the little way. So 2x is the same as 108. On the calculator, I'm dividing both sides by 2. And I get 54. Okay, that's fun. Is 54 plus 54 plus 72 180? It better be. Okay, now I'm going to, so I found that's 54. That's 54. What else can I do? I'm trying to get to U and I'm not there yet. Can I get this one next to it? Sure. Okay, what's 54 plus Y? What does that have to add up to? Good, 180. Okay, I'm going to take away 54 on both sides. And I get that Y is the same as 126. So that makes sense. It's obtuse. Okay, and I might want to make this picture bigger. Oh well, too late. Okay, that's 126. Okay, I am going to make it bigger. I'm going to draw the triangle bigger. Okay, if I draw it bigger, does it make the angle bigger? No. Okay, so there's 126 there, and we also have another isosceles triangle. This is triangle VTU. And I'm trying to get to angle U, but I actually want to know everything. And now this is the same kind of problem. I'm going to call these Z just for the heck of it, because I already used X and Y. Okay, now it's going to be kind of like this one. So we have 126 plus Z plus Z. How did I know those were the same? Because these had the same marks and the angles across from them are the same. That's the isosceles triangle theorem. And same kind of problem, 2Z and 126 is 180. And 180 minus 126 is 54. 2Z is 54. Divide both sides by 2. And Z is 27. Okay, so I'm done. No, you have to tell me the answer. The measure of angle U is 27 degrees. Okay, that answers the question. And not only did we answer the question, we solved the entire figure for all the angles. If I wanted to find the measure of angle T, I could add 54 and 27 together. And I've solved everything that I can. Last one. If the measure of angle CBD is 130, so when I read it, my brain goes automatically to the picture. If the measure of angle CBD is 130, what is the measure of angle BAD? BAD. Okay. The other thing my brain does is it looks right here. Hey, what kind of triangle is that? I'm going to make this picture bigger so I can engage with it more. Woo! All right, more fun. What kind of triangle is triangle ABC? They have all three marks the same. So the first thing after I read it, I'll put my 130 back here. Next thing I'm going to do is say, hey, look, equilateral triangle, no brainer. 60, 60, 60. Okay. So inside of the equilateral triangle, all the angle measures are going to be 60. Okay. And then the given information said that the whole angle was, maybe I'll do that. The whole angle is 130. I am trying to find angle BAD. Maybe I'll put a little X right there. Okay, so in order to do this problem, I'm going to get rid of that part. I'm going to figure out this bit right here. And for that, I'm just going to straight up do 130 minus 60. My work is devolving because I'm getting tired. The longest video ever. Okay, so this is going to be 70 Okay. And now if I focus on this triangle, what did these three add up to? 180. So we got 70 in this corner. What do we know about these two? Well, these two have to be the same because the sides opposite them are the same. So it's an isosceles triangle. These two base angles are going to be the same. Maybe I'll put 3 little marks in here. That one has to be the same as this one. Okay, so let's finish this strong. 70 and x has to add up to 180. I'm going to take away 70 on both sides. I'm going to be really tricky and just do this kind of in my head, but still show the work. That's 110. Divide both sides by 2. 55. 110 divided by 2. Did I get it right? Yep. Okay, I did it. That's not the answer. They want us to write the measure of angle BAD is 55 degrees. All right, that's a long video. Hope you learned something and it helped. Have a good day. Be good. Do your work.